Hi, my name is Fernando Rodríguez. I'm one of the co-founders of KeepCoding, a training company with offices here in Madrid and in California. Today we have the pleasure to have Douglas Crockford with us. He flew from the US yesterday, and we had the surprise to find out that we're neighbors back in California in San Jose. So even though he's not the father of JavaScript, a lot of people consider him kind of a foster parent because he got the language in its messy teenage years and helped it become a successful language, and it's a language that is taken seriously right now by a lot of people. And I think that's mostly because of your book, JavaScript, the good parts. And Douglas is also responsible for the JSON format, and he also wrote several tools that are very important to JavaScript developers, such as JSLint and JSMin. I'm not sure if I left anything important out.
Sounds pretty complete.
Sounds complete. Okay. And by the way, talking about JSON, there are some newcomers in that space, like GraphQL or protocol buffers, that kind of seem to be competing for the same niche in the ecosystem. Do you think that JSON will last as much as we expect JavaScript to last?
I expect JSON is going to be around for a long time. One of the best features of JSON is that it doesn't have a version number in it, so no one can ever change it. And that means whatever you're doing now that uses JSON will always work. That there's never going to be something that breaks it. And I can imagine.
Not even dates.
Nothing.
It's been fixed.
It's the way it is. It's fixed. So you can imagine that there are things you could add to it that might make it better, but I can't think of anything that's more important than stability. So I don't expect that JSON is the last data interchange format. There are going to be others which solve particular problems better than else. But for the general problem of allowing programs in any two languages to be able to communicate with each other and share data, JSON works really, really well. In fact, nothing else works as well. And so, because of that, I think it's going to stick around.
Okay, so our grandchildren will be programming JavaScript and using JSON.
I hope they're not using JavaScript, but they may very well still be using JSON.
Okay. So many of our students come from a non-computer science background, and I found that it's also your case. And even I am a chemical engineer transmuted into computer nerd. How did this call of the code get to you?
Well, when I started, there was not a computer science degree in my college, so I didn't have a choice. I took the few programming classes that were available to me, but the rest of the time I took other classes, which in retrospect I think was a good thing, because I got access to a lot of other things. My major was in communication. And it turns out communication is a critical part. It's not just enough to tell machines what to be doing. It's even more important that we tell each other what we're doing. And so being able to program and communicate, I think, is really valuable for me.
Now, that's a very unusual skill among programmers. We usually struggle to communicate with humanoid peripherals.
Yeah,
and dealing with humans is...
Yeah, because the quality of a code base depends on how effectively that code base communicates itself to whoever happens to look at it. And often you have programmers who think, all I have to do is trick the compiler. If I can trick the compiler into accepting this crap, then I've done my job. And it turns out not to be true. But we should think of a program as a piece of literature, and its ability to communicate clearly to us without ambiguity or error is extremely important.
Yeah, definitely. That's something that I also tell my students a lot of times. I think that your code is going to be read thousands of times and compiled maybe dozens of times. So make sure it communicates the right intent.
Yeah.
That's definitely interesting. Douglas, what would you recommend to someone who wants to start a career as a developer and doesn't come from a computer science background, which is increasingly common these days? What do you think you should have known back then?
Find a good teacher. And that's true of every discipline. Right?
Yes.
And if you can't find a specific individual, there are lots of books out there that are very, very good. Some of the classics, I think, don't get enough attention anymore, but are worth reading. Like The Art of Computer Programming, classic.
But that's a bit dense for a beginner, maybe.
It's definitely not beginner.
Yeah.
It's very advanced stuff.
Uh-huh.
But I don't think you should be allowed to call yourself a professional programmer if you haven't read that book.
Yes, definitely. And what about CP? It's also seems a bit forgotten right now, and that book had that effect on me. Now I feel like I'm a programmer. I know what I'm doing.
Yeah, that is such an important book. It makes me sad that they're not teaching Scheme at MIT anymore.
Or anywhere else, actually.
Yeah, exactly. Well, MIT was like the last place.
Last of the Mohicans.
Yeah, that they had this fantastic leap forward. And, people would trickle out of MIT and would kind of get those ideas filtered into other things. And, they've abandoned that.
I think that maybe the Rice University in Texas was still using. I think they created some interesting books using Scheme, such as how to. I don't remember right now how to structure or how to build programs or something like that. I might put a link later on. I don't remember the exact name, but it was also one of perhaps the main hubs that were teaching Scheme at this point. I'm not sure if they've abandoned it also, but yes, that's definitely tragic.
Yeah, the bad drives like the good.
What was that you say? Worse is better. We always come back. It's a bit frustrating about our discipline that
We're a lot better at worse.
Yeah, exactly. And always fall into the same mistakes every decade. It's a bit depressing. Right now, there's a clear binding between the Douglas variable and the JavaScript value. How did this kind of love and hate affair, or love affair, got started?
Yeah, I did not set out to be the JavaScript guy.
Okay.
It was never something that I wanted to be. But I accidentally discovered some things about the language which were surprising and important, and also eventually turned out to be true. And that kind of completely changed the position of that language in the world. And I told the truth about the language. Usually if you read a book about programming language, it's all great. Everything's wonderful. And I wrote a book that dared to say, well, some of it's good. It has good parts, and it has bad parts, and maybe more bad parts than good parts. But the good parts are really good. That's what I mean. No one had ever done that before, at least not to the same extent that I had.
Okay, and when was that approximately when you got started with JavaScript? You realized it?
So I first saw JavaScript in about 1995, and I thought it was the stupidest thing I'd ever seen. And then I had the occasion to take a look at it again a few years later, and I thought, okay, I can make this work. And then that was a really painful project. Got it finished on time, got paid. That was good. And then I had some free time, so I thought, well, maybe I'll try to learn the language. Because like everybody else, I just started.
You just got started.
Yeah. I think I know what this is.
Yeah.
Turned out I had no idea what it was. So I read the standard, the ECMAScript standard, which was very difficult reading. It's not a well-written document. But I read it and I figured it out, and I had this epiphany. It's got lambdas in it. There's this close affinity to Scheme, which was intentional. And I intentionally made it Scheme-like, but didn't tell anybody.
I heard somewhere that he tried to write a Scheme interpreter, and the project was refused.
He wanted to write a Scheme interpreter just so he could learn Scheme. He's a brilliant programmer. The way brilliant programmers learn is by experimentation. And people at Netscape said, we don't want Scheme for this. We want something that people will like. So make it look like Java.
It didn't work exactly.
So it would look like Java.
Uh-huh.
And it turned out most of the bad parts of JavaScript are due to inheriting it from Java, which inherited from C++, which inherited from C, which inherited from B. So there were mistakes that were made in B that have been propagated in almost every language since then. But they just look stupider somehow in JavaScript. I'm not entirely sure why that is.
Okay. Douglas, you have a bit of an artistic background. I've met many musicians that became very skilled programmers. Do you think that programming is some sort of art, or there's some correlation between the skills necessary for an artist and for a programmer?
Yeah, I think programming is the most creative of all creative arts. And because we're actually creating, we are like gods. We can make things that can do things, right, that have behavior, and we make them out of thought.
Yes, definitely.
We're not, great gods.
Mm-hmm.
We're
No.
little incompetent geek gods, but we have that, and so there's a tendency of programmers to think of themselves as gods, right? You know what I'm talking about. And that's slightly justified because we have that creative power.
And we build things out of nothing.
Out of nothing.
Nothing. Yeah,
Stuff out of bits.
it's true. Yeah, absolutely. Absolutely.
And it doesn't always work. And when it works, it doesn't always work right.
Doesn't do what it was expected to do,
It's
but it came out of nothing.
Yeah, it's not quite that we could say magic word and make stuff happen. It's a lot harder than that, but not that much harder.
And in the Sick People, there's a lot of this theme as talking about developers and programmers as magicians, and there's a bit of this. There's a quote, called it, "We are gods," or something like that, that we can bring the spirits that inhabit the machine back into life, and which I think it's quite interesting.
Yeah, and when the program works, it's like magic.
Yeah, it's magic. It's magic. You feel like God, definitely. Even if you end it at 2 a.m., it feels wonderful when it compiles and works.
Yeah.
Douglas, what's the best approach to learn JavaScript right now? Do you think someone coming to the language for the first time should stick to the good parts, or you have to learn the crap in order to avoid it?
No, you should definitely stick with the good parts.
And forget about the rest?
Forget about the rest. You are not paid to use every feature of the language. You're paid to write good programs. And you can write good programs much more easily using just the good parts. So it's not a burden. It actually makes it easier.
But what if you get into a shop that already has substantial code base, and that code base is not that good? Should you find another job?
Well, yeah, there's that option. The other is to try to make them smart. But one of the things you can do when you go to work for a shop is try to make it a better place and try to show everybody how to increase the quality of the work that they're doing.
Okay, so stick to the good parts.
Stick to the good parts. There are some people who think it's like jazz. First you learn the rules, then you break the rules. No, it's not like that at all. It's about writing good programs that work.
Okay, sounds like a good advice. Your book, JavaScript, The Good Parts, is surprisingly thin. It's less than 200 pages, while the other book, JavaScript, the complete reference, the definitive guide, is more than 1,000 pages. That's kind of scary, especially for a newcomer. Do you think that with ECMAScript 6 that imbalance is reduced, or there's still that amount of crap in the language?
They added more crap actually. So there are definitely some really good parts in the S6. My favorite two new features are proper tail calls, which allows us to do continuation passing style in JavaScript, which is brilliant. That's really important. Ellipsis, which gets rid of the arguments array, which was horrible. And what else have we got? Weak maps.
Mm-hmm.
Weak maps work the way objects always should work, and that any object can be used as the key.
Mm-hmm.
Unfortunately, they didn't fix objects. Instead, they added another kind of object. So they made the language more complicated instead of fixing it. The reason for that is that because it's a language of the web, it cannot be fixed. Once a bad feature goes into the language, the web will become dependent on it, and you cannot.
Yeah, that's true. There's no way to get rid of the...
You can't get rid of it. And ES6 added a lot of new bad parts, and they are now stuck in the language.
And what about arrow functions? A lot of people seem to be excited with those.
Yeah, they're excited about it. When it was first proposed, the justification was that the word function has too many letters. It's too hard to type. So there's this new thing called keyboard macros. So it's too much to read. We can't read all those letters. So we put in this thing, and unfortunately we screwed up the syntax of it, so that braces are ambiguous. It looks like an arrow function should be able to return an object literal, and it can't. And we keep having ambiguous things in a language we know from experience causes errors. And we could have designed it correctly, and we designed it incorrectly, and we'll never fix it. So, because of that, I'm not a big fan
of arrow functions. Okay, that makes sense. And there's right now kind of a new coming of JavaScript. We're getting increasingly demands for training, JavaScript training, both from corporate clients and individuals. How do you think this is going to evolve in the next few years? Do you think it's a good investment to learn JavaScript? Or?
Oh, definitely. JavaScript is finding its way into more venues now, so it was always the language of the browser. It's always going to be really important there. It's now found its way into the servers, and it's starting to find itself in embedded systems. And it's all over the place. I don't think we're ever going to get rid of it.
And since it's getting into many different places, do you think it might come at some point that a different version of JavaScript that only works on servers or for mobile apps or whatever, that gets rid of all the cruft that cannot be removed in the web? Do you think that might happen? Might be a...
I think if we're going to make a significant breaking change, we should make a new language.
A new language.
Yeah, because there's just so much crap. Excuse me.
Yeah.
That's a crap.
No problem. Don't worry.
There's so much crap in this language. And some of it is really foundational. It's very, very deep. And I would just, let's start over. Let's just make a nice new clean thing. I think it'd be a reasonable thing every 20 or 30 years. Every generation, it'd be really sad if it turns out JavaScript is the last language, right? That we're using JavaScript forever. You don't want that. You don't want your children writing in JavaScript, right? No, for the kids, we need a new language. So what I'd like is if we could take all of our knowledge and experience from JavaScript, recognize what did this language get right, because it did get some stuff powerfully right. And let's just do that in the next language. Let's go forward.
Do you see yourself doing that?
I've been working on that for years, and I'm not satisfied with where I am yet. So in the meantime, I'm hoping someone smarter, more talented will figure it out. Because it's a complicated business. And I've been at this for years. Brendan had 10 days to do the original language. And it's kind of remarkable how much he got right in those 10 days. He's a very, very bright guy. But you can't get it all right in 10 days.
It's easy to criticize JavaScript, or at least the original implementation, if you forget that he had 2 weeks to create it.
Adobe tried to make a modified JavaScript, which ended up being called ActionScript, and 3 versions of that. And being kind of the same but different led to incompatibilities, confusions, and weirdness. So they would have done better if they just made it a clean new language.
Oh, Microsoft did something similar back in the JScript days, so it wasn't exactly a completely different language.
It was exactly the same. JScript was Microsoft's implementation of JavaScript.
But didn't they include some new features or?
Yeah, but they didn't get used. so
Okay.
it didn't matter. They added some bad stuff. Unfortunately, nobody noticed, and they didn't get copied into anybody else's version. Didn't get into the standard.
Okay, so we're not paying for that.
Yeah, so
Right.
that's fine.
Uh-huh.
And so it's really good to be creative with a language if no one is using it, which is why language design is such a great hobby.
Uh-huh.
You just do stuff and you can modify it, and as you know, oh, that was a mistake, I'll completely change the way that works.
Mm-hmm.
But once a language becomes popular, you lose the right to make changes to it. And when it becomes the most popular language in the world, which is what this one's
The case.
did,
Yeah.
we're completely screwed.
Okay, so if you're successful with your language, in the end you get screwed. That's the conclusion?
Yeah.
Yeah. Okay.
So that's why I think we should make a new one.
Uh-huh. Douglas, it's been quite some time since we saw you last time here in Spain, about 4 or 5 years. Can we expect to see you again around here?
Yeah, just waiting for an invitation.
That's very easy to fix. We'll talk about that later. Douglas is here in Madrid to give a talk at the KeepCoding Connect conference that we organize every year here in Madrid. And this time we're going to talk about one of the most infamous villains in programming history, the go-to statement.
The go-to statement.
Go-to statement. So it's getting a bit late. Shall we go?
Okay.
Oh.